How's it going? It's Liv. And today I'm just going to show you something real quick, and this time it is going to be real quick, okay? So, this is the test file I have for the new parser that we're making, and the constructor for the new parser is, appropriately named new parser. All right. So, basically, what we have to pass it the language that we are using. So, using the langdefs model. So basically we have a language definitions folder, okay? And these are just a Perl module like any other, right? And these, in a kind of hacky way, will be injected into the lang module itself. And so with the proper language definition loaded, you can access that language definition like so. Sounds good? Okay. So anyhow, this is just, it's basically just an object holding, I would call it more a container than an object, but it just contains data and methods that are of use in detecting common patterns within a language. Okay? All right? Okay. So what we are doing here is we're going to read an entire file and create a basic pass-through, right? Now, the way it was just a short while ago was this initializing this parser would give us a series of blocks, right, that we can pick from directly from the parser, and all of these blocks correspond to names of subroutines. But we had no good way to access the global scope, so I went ahead and fixed that. And where is it? Oh, right here. Okay. So basically, we are applying the same processing that we give a subroutine. Same processing, exact same. We're applying it to the global scope. Whatever is left of the global scope after all of the subroutines have been folded. Okay. So once they have been abstracted away into a single token, right? Whenever we reduce the subroutine to a single token, we just leave that in there and replace it, as it's common practice, with the cut format, which is basically just a good old cut token. But oops, give me a sec. I want to show you the definition, right? So it's basically the same thing, just in this convenient format that we can just insert things in here using a sprinter or printf if you want. So code fold. So basically this gives us a string that we can use with the exact same processing that we give the subroutines. We can process the global scope, or the file scope, if you will, which would give us another tree. And let's just here I am fetching it, right? So it's named root, right? So if you want to fetch a subroutine, your ID would be the name of that subroutine, okay? In here, we want to fetch the file scope, so we passing it root, okay? Okay, so we are fetching that block and seeing the parse tree for that block, and then printing out that that tree, okay? So let's take a look at it. Okay, so I'm going to run a little update. Okay, nice, and then I'm just going to run the test script. And it gives us an overview of the file basically. So here you see, we can see the name of the package or use declarations, right? So dependencies, some of the global scope stuff, right? Here is a read-only hash that I declared, nice things. And here is the subroutines abstracted away behind a single name. So what's this actually good for? Why do we need it for? Well, suppose we want to get a list of all the dependencies of a file. Okay, think of that. So how can we do? we have this method, which I was refactoring, quote unquote, the other day, yesterday actually. And utilizing this method for the node class branches in, we can find every branch in a tree that contains whose value matches a given pattern, right? So suppose we wanted to have a list of, I know I said dependencies first, but let me just show you. If you wanted to see all of the globals that are marked with the our keyword, well, we could try, and I'm not going to expand them, right? So if we call the recurse function, we would be expanding those branches, but it's not what I want to do. Let's just print them out, okay? So what we'll get basically in just a couple of function calls is the list of all of our globals marked with our, right? Pretty nice. If you want to get the list of dependencies or any modules, rather the list of modules being used by the file that we're reading, we just replace this pattern match with use. If we run that, what do we get? The list of dependencies. Well, isn't that nice? So there is one caveat here, right? So sometimes, and this is actually, I think I touched on this some time ago. It's kind of bad practice, I feel. It's a little bit hard to avoid, actually. Sometimes you will be able to have a reference to an object created by a module that is not directly dependent, whom I am sorry, it's a little bit complicated to explain this. Sometimes you will have an object within a module, and the object the module from which that object comes from will not be listed among your use, right? And that will still compile and run, so it will still be valid Perl, because if the object was created somewhere else and then passed to your module, really no problem, right? So the module is still loaded in memory, so you can access all of its methods. So you don't have to list it as a dependency, but it is a dependency in a sense. It's an implicit dependency, let's say. So that might be a little bit of a problem. I'll see about it someday, okay? But for now, this is for at least the explicit dependencies, we can find them this way. And yeah, we can just see which version of Perl the script is using. So there's this little problem in which the dot, I mark the dot as being an operator, and so yeah, it would just split that. The tokenizer will split that. So I would like it to make it so the tokenizer looks into version strings as it would a whole value, right? So without splitting it up. And same thing for package names, right? So you can see it, yeah, it splits them up, and that's like, it's not really a problem, because like if you were iterating through the leaves to try and figure things out, and and the root says package, then whenever you encounter something that starts with the 2 colons, that it's part of the package name. But yeah, it's better if the whole name is already there for you. Same thing for this. If you just want to know the version, it's better to have it as a whole string and not have to to be making exceptions for every keyword in how the values are read, right? So yeah, we want to take care of that. And so that's a perfectly good excuse to just jump into the internals of this thing. Okay, so let's go first and foremost into the node class, and I also want to take a look at language. Okay, so we're working with tokenize2 because there's another tokenize function. It's going through the deprecation cycle, right? There's still some modules that depend on it, and this is the new system. It's experimental. I don't want to just replace everything that's older than this just because. One, because it would be a very arduous task, a very long code refactor, which I can do, but it would take some time. And besides, I'm still not sure if I will keep this system exactly as it is, right? So I want to make sure that the system is polished and well designed, right? So I still haven't encountered like very blatant design flaws, but they might be there. So just in case they are there, let's not play with fire. So anyhow, here is basically what's doing most of the tokenizing. Okay, so I have two gripes with this actually. One, this should not be a constant. It should actually be taken from the lang, right? So for every language definition, you have patterns set. And so what's a valid name? That is a language rule, that is a language pattern. And generally it's the same rule for all languages, but just in case you ever want to make a language where, I don't know, lowercase letters are not allowed for a name, I don't know, maybe you want to do something like that, right? So yeah, you want to have that as language rules. Similar thing for operators. Maybe you do not want to recognize certain symbols as operators. Like, who says you cannot do that? Okay, so yeah. And labels, your language might not even have labels, but if you do and you do not want to use the standard syntax of label and colon, yeah, it would be kind of nice to be able to do that, even though as it stands now this is also a constant, because quite honestly I do not know of a language that does not use that syntax, so I just sort of postponed it, I guess. But yeah, we want to make this as constant-less as possible, right? So all of the patterns we are matching against should all derive from the language definition itself. So we already have defined the scope bound field, which is basically this, and for most languages it will be this. But just in case your language isn't, right, we want to give you the ability to change that. So yeah, that's bound singular. Okay, scope bound, and now we change this thing in here with scope bound, and that's a wrap. All right. Okay. So now numbers are mysteriously absent from this, and my bad. I really didn't notice. I suppose I wrote it in a little bit of haste. So okay, here I have a list of patterns for multiple types of numerical literals, right? So we got hexadecimal and octal and binary, of course, and decimal. And the cool thing is that decimal includes floating point, right? So it's both things in one pattern, so kind of cool, right? Okay. From this, a regular expression is created, if I'm not mistaken. Yeah, the num3. This is a hash path, which basically means hash pattern. So from the keys of a hash, we derive a regex. Okay, so we can actually use that. So let's see. we want num, and let me just be a little bit more orderly about this, okay? And yeah, some attributes are in all caps and some others are not. I have to fix that, I'm sorry. But anyhow, for now this is good enough. So I'm going to do names first and then numbers, okay? Because the thing is, the order actually matters, okay? So something will be, so hear me out. A keyword could be a valid name, right? And so we want to check for keyword first and then for name, right? Make sense? Okay, good. So I suppose scope bound should be after operator, because the scope bound in a sense is an operator, but I like making that differentiation. Some people do not. I like to. I like to do that differentiation. So, okay, so do we have version strings in here? Because I know my I know that my syntax highlighting does recognize that, so I have written this pattern. Okay, so it even recognizes when you put an A or B, right? So that's kind of nice. So if I put an F, oh right, so an F would be a float, but if I put a C, the C is not highlighted because that is not recognized as part of the version string. If I put just a B, that's just a name. If I put B and something, that is a version string. So yeah, it does mean that you cannot say B0 and B1 and B2. Yeah, you cannot use those names now. But honestly, I mean, it's not the worst compromise, you know. So yeah. Okay. This might not be here, so I cannot look just for B because that would be too much. Let me see if I can find a version. No. My bet is this is part of SciGen. Is it? Let me see. B string. Yeah. Okay. All right. So. So the pattern only exists as for the syntax highlighting generator, which is somewhat hooked into the language definitions, right? So from the language definition, we create the syntax highlighting files. Yeah. I guess what we can do is just make this the default, turn this into a default and just be done with it, okay? Nice, okay. So yeah, the A and B is for alpha and beta, right? So this is what allows you to write something like version 0. I don't know, 3, no, I said 3, not 4, but 0.2a, right? So it's an alpha version, or B, it's a beta, whatever. So yeah. With that, now we can just eliminate this, because now if your language definition does not define a pattern for a version string, it will just use the default. Nice. So okay. That I think that would be about that. So now we can, over in, yeah, I can close this. Over here, we can say this string and just take that pattern. And oh, you must be wondering what a language definition looks like. So I'm just going to show you. It's just a big old hash, right? So you say langdefnet, and you just pass it the list of attributes that you want. these are the ones you really, really need to put in, right? These are the ones that you really, really need to put in. You need to give it a name and an extension and the header, right? So the header would be like, what is the first line of, what would the first line of such a file be? In this case, because, yeah, how else am I gonna run JavaScript without a browser? I think Node is the only way, but if there is a better way, I'd like to know. Anyhow. And yeah, and then it's just, list of keywords, right? So this is for flow control and directives, intrinsic. Well, you can read for yourself. There is no types. There is no types, because JavaScript, right? Anyhow, use TypeScript. Use TypeScript, people. or just abandon web development and come to the seaside, and you'll starve. You'll probably starve. It's really hard to get a job. It's really hard to get a job when you're not, when you're not when you're a C programmer but not an electrical engineer, right? Really hard. Right? If you're doing embedded systems, yeah, this place for you. If you're not doing embedded systems, if you're doing like desktop development, yeah, you're going to starve. It's what I'm saying. Yeah, it's not gonna. You're not gonna have a good time. But anyhow, my joblessness aside, with this we should be able to detect the version string. So let's try it. Okay. So we're going to detect numbers first, just because. There is no way that this could be confused with this, right? So there is no ambiguity in there, but I don't know, just because it's something I would like to check first. In this case, it wouldn't make that much of a difference. And yes, we are checking for name first. And so if you are dumb enough to declare this as a variable, when this, by your language definition, means version string, yeah, it would still count as a name. Yeah. So just putting that out there, it's not going to break your programs, okay? But anyhow, okay, so let's see about that. Let's run our update. All right. People talk about empowering so much nowadays, but nothing is to me more empowering than knowing that the whole build system is something I built, right? I built the build system. That is empowering, Okay. So yeah, so this one is still broken. We have to fix that as well. But let me just check that the version string now reports correctly. Okay. So let's go back and see our hours. And not quite. Not quite. Because operator comes first. Because operator comes first, okay. Alright, so that is a little bit of a problem. Okay, so you want. I'm not entirely sure this is a good idea, but what the hell? Oh, since I'm at it, I'd like to put this in this order. Yeah, that looks about right. Let's try it. Oh yeah, I have to run the update. Still not quite right. Let me think about this. Huh. what could be getting in the way? Because name is first. Well, okay, so now version strings will break your programs. Okay, that's a compromise I'm willing to make. And here we go. Okay, so your program is now broken. If you ever use B0, B1, B2 as a name for a variable, now your program is broken. I'm sorry. That's just the way the cookie crumbles, you know. But okay, so now we can get version strings, right? Which is kind of nice. So now let's do the same thing, but for package names, right? Because in case you've already forgotten, right? So we have this little problem in here. So basically the same thing, right? So this is detected as a valid name, and then it sees the operator, and that's not part of a valid name, and so it cuts right at that point. And yeah, if this was considered an operator, it would cut the two columns and then put this thing as if it were a name, right? But no, we want this whole thing as one token, okay? Because it's a package name. We want the whole thing. So I do have a regular expression for this as well. I have regular expressions for everything. I have regular expressions for days. And it's here, the RFC. So it's the reference. I think it was the referencing, and it was something else as well. But yeah, the referencing. I don't remember why I named it that. I believe because I couldn't think of a good name to call this operator and this operator, right? Because suppose right, so this is like a C thing, right? So you have your pointer here, and when you want to reference that, so I actually should be struct. Right, so when you want to access one of the fields of a struct, you have to do it like this if this is a pointer. But if this is not a pointer, so it's just a plain struct, you do it like that, right? So yeah, because it was yeah, I didn't know what the hell I'm supposed to call that, so I just came up with a name myself, you know, to the confusion of everyone else. But what you gonna do? So anyhow, we already have this, so we could create a regular expression to just match an entire string utilizing this kind of thing. But it would include the arrow, and it would include the dot. So I'm not entirely sure if that's what I want to do. And by the way, this group should be non-capturing. Right, that's better. Okay. And this group should be non-capturing. And wait, I have to count. I have to count the parents now. So okay. So what is this supposed to be? Detecting regular expression. I think this is no longer in use. Likely not. Huh. Okay, so it's 1, 2, 1, 2, 3, 2, 1. Wait, what? Oh, no. Oh, okay. Alright, so this entire thing is a whole group. Okay, good. Yeah, that's a bad way of counting, but yeah, that's what I got. Okay. Non-capturing, and you know what? I'll do this later, because if I have to go through every single one of these, it's gonna drive me crazy. Okay. So there is a here it is. Okay. So this one this one kind of gets the job done, but only halfway through. What I would do is I would just well, this is kind of where this gets kind of weird, right? Because I have to take this concept and apply it in a way that would work for multiple languages. So, my favorite thing of all time, right? Having to answer this kind of philosophical question. Huh. I'll tell you what, I'm just going to do it the lazy way, and I'll think about the good way later on, okay? Let's do this. I'm gonna try and use this syntax, which basically it will replace this token with the variable of the same name, right? So, because I can't reference the hash before it's created, and even if I could, it would be expected that maybe this would be redefined by the language definition, and so it's not what names would be is not known until names is defined, and so this is basically a placeholder. How do you say? A placeholder token, and we use the DRFC. And what will differentiate it from whatever this is, because I don't quite remember. What I'm gonna do with this is I'm gonna try and make it recurse. Okay. So it should be a name or a DRFC character, let's call it that, a DRF sequence, and then recursion. Okay, so recursing at the start of the pattern. So let's put it in the same line just to be absolutely clear about what this is doing. Okay. So let's let's group this just because I think it will look a little bit nicer. Pretty sure it wouldn't be necessary. Okay. I'm not entirely sure if this is going to work, but let's try it. Okay. So what I'm not sure about is if these tokens will be expanded when they're inside the QR, but we'll find out. So next to this one, we'll do hierarchy. So higher for hierarchy. And I'm gonna have to put this before name. So yeah, I'm just breaking your code all day long. Okay, so that is a mess. Would you look at that? That is a gigantic mess. Okay. Okay, so this was not supposed to happen. So that's 446. Oh, I know. Okay, so the expansion worked, which is amazing. Inside of a regex, inside of a frigging regex, the expansion works. You see, this is why we like Perl. Anyhow, and I didn't even have to use the backtick. Amazing. Oh, just amazing. Okay. It's telling me I have an unnecessary parents, but I don't quite see it. So this one closes this one, and this one closes this one. So where is the problem exactly? All right. But still not good enough. Okay, I have another way to test this. No problem. Let's say, actually I can just say lang Perl. Yeah, isn't that nice, eh? So my higher re, actually I can say re because higher re sounds too close to diarrhea. I'm sorry, but it does to my mind. So anyhow, how long have I been recording? Let me just check here real quick. Okay, so about 40 minutes. And I am recording, right? Yeah. Fear of talking to myself. Yeah, that's a big thing. So anyhow, let's say just print out if some yeah, like this, and let's say bisu and the MTL and the MTL. I should change that name. It's incredibly hard to pronounce. Yeah, like FND MTL is like, dude, slow down on the slow down with the abbreviations, you know, like yeah. Not using vowels is sort of like it's a curse, but it's also something I love. Yeah. So what I want to see is where exactly the regex goes wrong. So what I'm just going to first off print what we all already know, just to get this thing going. What are you talking about? That's not correct. So one, it says, so this is kind of crazy. First off, it says that it did match. But it's uninitialized. What? Give me a second here. I need to. Oh no, it did not match. Okay, here we go. Okay, all right. I'm game. Okay. So let me just see the regular expression by itself and then can decide. Okay, so now it did not expand properly, so that's a problem. Okay, because this is a variable. Pearl, we need to have a talk, buddy. Pearl, really, we kind of need to have a talk, man. This thing you're doing, like, this is a variable, and 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 this is a variable. Like, dude, and this is a variable as well, and this as well. I mean, and this one as well, and this one as well. I mean, people, at some point, you gotta stop. At some point, you gotta stop. You know? I mean, this shit is crazy. Okay, let's just escape this and see if that helps. No. So that presents us with a problem. We actually cannot do the expansion. No problem. What I can do, however, two things I would like to try. First off, using single quotes, maybe. No, it will always try and do interpolation, which means I have to make this just a plain string. Which also means, this is getting problematic. Wait, what? Okay, that is not right. Oh no, wait. It's because I have to update. Okay. All right. Okay, so it does the expansion. So now I have to do the expansion first and then pass this through to the QR. Okay, so it's 2 steps instead of 1. That's fine. So let me see, the vrepl, it's the function that's doing the expansion of those placeholder tokens. Okay, so we need to go pretty down. Okay, so right here. Okay, and I'm just going to do it straight up, and then we'll see about whenever we have to do this for more than one, we'll do it for more than one. For now, I'm just going to do it like this. Okay, because this 2-step, replace then turn into a regex. Yeah, I might have to do it for more than one of these patterns, but just to get this one working right now. Okay. Okay, and that works just fine, but I do need to add the x modifier, and there we go. Okay, so now if you don't put in the x, the white space is taken as part of the regular expression, and so any spaces or new lines are taken as being part of the pattern that needs to be matched, which yeah, terrible idea. Terrible idea. So yeah, let's check if this matches, and it does match. Done. So now let's see if we did everything correctly. Now we should get the package name in its entirety. Okay, so let's just run the file, and so close, so close, but no. Because it must be, oh no, well, I'll be damned. In a good way, but I'll be damned nonetheless. Huh. Kind of crazy. That's kind of crazy. Just once again, if I if I do it manually, it matches, which means that it must be matching with something before it. But again, that's kind of weird because it takes precedence over just their name. So, how does that work? Huh. Let's try this again. Make it a non-interpolated string. So let's say package su fndmtl. Okay, it matches, and then let's actually capture it. Okay, so what was that? That's not correct. That's not correct at all. Oh, because it starts with a name. Because it begins with a name. And so it matches name first, and then it says, I'm done here. And it exits. Something like that must be. Let's try diary. Or diary. Or diary. So let's take out the alternation. And no match. Okay. Okay. I'm game. This is interesting. Well, can I not make it names and this repeated any number of times? Can I do it like that? Nope. Okay, so but if I remove the package keyword, would that work? Yes, that does work. And actually, I should say at least once, no? Because else it does much. Now, it would be kind of weird if you had a package name that does not have the double semicolon, but that would still just be a single name, and thus, for the purposes of what we're trying to fetch, same thing, right? So we want the entire package name as one group, as one value, and that's what we would get in that case. So same thing basically. All right, same result. But if I don't, oh, there we go. Yeah. Okay. All right. So now it works. Now it does work. Okay. Well, all right. Works for me. Let's see if we can match something with 2. Let's see. Okay, so apparently it can, but let's just make absolutely sure. I'm going to comment this out. Let's try passing something that's a little bit more that has more than one package and more complex names. So let's see, it should be, no, it's hacks. Sure. Okay, let's try that. All right. Okay, let's try it's no, yeah. Let's try now. Okay, so yeah, it does match it. So okay, pretty fucking good. Um, hmm. Well, next up, what we could take a look at is making it so every node that's below a package belongs to, is a child of that package, right? Because anything you declare after the package directive is directly below it. So hierarchically, we should respect that, no? So let's try that. Um, have a, I have an idea. I have a little bit of an idea, okay? Let's try it like this. I'm not going to do this with a map because it would be too confusing. So for my branch in branches, and this is the last thing I'm going to do, like real quick. My branch in branches, I know that the first value of the package with that the first leaf would be the name of the package, right? So we've ensured that that is the case, and if that is not the case, then we have an error. Okay, so yeah, we'll check for the error later, but for now, let's just fetch from our leaves. The first leaf we know is the name. Okay, so package name is equal to that. Okay, and so now we can say my end call. Oh no, wait, no, it's not needed. Wait, we're gonna do it like this. We're gonna get the index of this node. Okay, so let me just go real quick to the initialization, and yeah, it's index. Okay, just making sure. So my index is branch index, and why do I need this? Because I can utilize that index in order to fetch from the tree. Okay, so I can say tree leaves and pick the node directly after it. But more to the point would be converting this into an array, and say my children, and now I want to say children, I want to take a slice, right? So or index +1, and I guess up to the next package, right? So we should check what the next branch is, right? Because we have all the branches that have package in them. So we can look ahead. We can look back and we can look ahead. So I guess I'm just going to do it the straight up way. Okay, so we're going to have a pointer. We're going to have a like an incrementer, like a counter. Incrementer, that's such a fancy name. A counter, right? So you iterate and the thing goes up, right? So simple. So okay, we would have to go from index begin to index end, and index begin, I guess beg index, nah, well, same thing. So I'm just going to add 1 to this, and the index end, we're gonna have to do a little this is going to be slightly more tricky, but not so much. because what we have to do is take from branches, take take our I, right? So the our counter, we have to do I plus 1, and actually I should do a check, right? So my ahead, and if defined ahead, right? So if we actually have a branch there, if we don't, we just say that. Actually, let me just define this here as just being 0. And what I'm going to do, or rather, I'm not going to give it a value. Okay, so if it's not defined, then we know it's the end of children. Okay, just order this around. And yeah, this is a test script, but nothing stops me from just copying and pasting the thing I tested into production, right? No problem. It's just Control X, Control V, easy. It's cut and paste. So yeah, what I want to do is if we do have a tree, that's the more complex case, so I'm going to handle that last. But the easy case is just, actually I don't have to redeclare it. It's just end of array, right? So take whatever's left, and those are this is the last package defined. So just take all of that. And then the other case is we have to take the index of the branch, of the ahead branch. Oh, and actually it was not that complicated. See, simple. You just take the index. Okay. We take our slice, and so what we want to do is this will be a list of nodes, by the way. So we just overwrite in here. We overwrite the original array with the slice of that array. Like the rest, we are not interested in it. Okay. So what do we do then? We have a function for that. It's called what is it called? It's push leaves. We push leaves. We pass a 0, which means do not overwrite the current children of the how do you say? Do not overwrite the current children of the leaf of the branch. And then we pass the list of nodes. And let me just double check that that is the case. Will be self overwrite pending. Okay, good. Does it do a CLLB, and does CLLB do a edextrav? It doesn't. Not too good. So yeah, you can read the comment, right? So CLLB discards the blank nodes, and edextrav reorganizes the indexes. So because if we're moving nodes around, we need to reset the indexes there. We can just let me think about this. What's in CL first and foremost? So I have to reorganize. I have to do two. It's a two-way thing that we have to do. First, we have to reorganize. We have to get rid of any blanks that might have been left over for whichever reason, and then we have to reassign all of the indexes to the nodes. But this is for the leaves, for the branches from which we've taken leaves, right? So now we have to go to the branch on which we've pushed those leaves and do exactly the same. So I have to apply this to self. All right. So I don't know why I didn't put this in like the first time around, but just with things that happen, right? So okay. All right. But now I'm thinking, this might not be the best way to do it because we will be pushing to the branch that has the package, right? So the one that has the keyword package. And yeah, here's kind of the thing, right? I like having, you know, that branch having the first value be the name, but I also would like having the next values be like the, I don't know, something else if there ever is. Like, I don't know, maybe you can say package name something like this, right? Or arguments, like when you use, you know. I don't know if that's a thing or if it'll ever be, but just to make sure, what I can do then is create a new node. Okay, so sorry, I just kicked the microphone. Okay, the microphone stand. So what we should do is create a new branch. Okay, and just push everything to that, and so it should be branch and children, so this will all be a single list. Or I guess I could unshift from children. Let's do it like this and see if that works. If it doesn't, we'll find out. That's kind of my catchphrase at this point. If it doesn't work, we'll find out. Okay. We have to create a new. We have to create a new node. Okay. This is slightly more complex than I thought it would be. Well, no problem. Let me just get the frame. So I need to say and the frame that would be RD. Do I have the? Where is it? Where is the? Am I going crazy? Where is the RD line? What happened? I deleted it. Okay. How did that happen? And let's take node itself. And it's kind of nice, right? Because you just say file name and the thing. Right? So yeah, this would only work with files. We would have to adapt this so that it can work for a naked string as well. But yeah, you know, someday later, it's a niche use case that I don't really want to get into right now. Like, it's good for when you want to pass one-liners, right? So you want to have an executable that parses like a command line, like a command, right? You want to parse that as if it were a line in some language, right? So yeah, that's nice. There is a very nice use case for that, but I'm not gonna be doing that right now. So yeah, this is good enough for now. So anyhow, I have to take from the program. I need to take the node, right? Because it has a container for what is called the frame, right? And frame is basically a shared context among various instances of the same class. Sounds confusing? It's not. Okay, so suppose you have an array, right? Suppose you have an array, right? And in here you have like a bunch of objects, right? So object 0 to object n. Okay? And all of these objects are created within the same context, right? Suppose within the same scope, right? And so there are certain pieces of data that they share. And so suppose you make that a class attribute, right? Seems sensible. You could do that. Just have a class attribute, and that is the shared context between all of the instances. But now suppose that not all instances of the same class share the exact same context, right? Then what do you do then? Well, the idea of a frame is that whenever you want to create instances of a class within a given context, you make that context into a class, right? So that context, it's its own class, and then you just instantiate that, modify its instance attributes, and that is effectively the shared data between instances of the object class, right? So it's basically a container. It's basically a container with some variables, right? So going back to the array analogy, suppose that you have this here. Suppose this is, I don't know, index 8 onwards, right? And the say that from 0 to 7, from indices 0 to 7, you have from 8 to n you have your instances, and from 0 to 7 you have attributes, right? So attrs 0 through attrs actually 7. Okay, imagine this. Well, then through this array you can access the instances, and you can access the shared data between those instances, right? So it's not, it sounds complicated if you explain it in object-oriented programming terms, but when you get right down to it, it's just a big old block of memory. It's just a big old block of memory, and that's that. So yeah, that's basically what the frame is. Okay, and the thing is, we need the frame in order to create new instances. That's basically what. So okay, I need to create a new node. So I'm going to say let's just say my package, because this is going to be like the package root. Package root, I like that. Package root. Okay. So it would be nd frame, just init, just initialize a new, and we have to pass it tree, and then we pass it the name, so package name, and this would be the value at the value of the new node we created. Now the next problem is we need to move all of the nodes from the tree into the newly created one. So actually, instead of calling this from branch, what we should do is call this from package root, right? Am I driving you crazy yet? Okay, now let's just try and get actually, let's just print out the whole tree. So it should be tree and breach. Okay, so breach out the whole tree. Let's see if it breaks. Oh, hoo. Package name. Global symbol package name requires explicit package name. Did you forget to declare my package name? You know, that's overly redundant. I just misspelled it. Okay. Or the frame. What you talking about? New frame, new parser. Okay. Huh. Oh, this is no. Wait a minute. Wait a minute. What is this thing doing? This is not correct. I mean, no, this is no. This makes absolutely no sense. And what the hell? The extract should be implicit. There we go. Okay. Okay. Okay, so the node value is not correct. Give me a second. Okay. So, right, because it has to be value. Okay. All right, there we go. So yeah, this is redundant, right? This is redundant, but just in case we are searching for the keyword package, we would like to have that in there, okay? Yeah, we could pluck it. We could pluck it, and that would be that. But what's the fun in that? Well, if I find that I want to do it, we can do it. But anyhow, now when we search for package, we get the subroutines that are part of that package. So nice. Now we can say, suppose we want to look for a particular package, right? And we want to get all of this stuff within it. What do you think we can do? We can use branches in to find. Let's see. Suppose we want the base class, so Visu node. And now we want to see. We would know it's only one. So the let's say package MD. Let's say it's this, and we would know it's always the first result because we cannot have more than one. So actually, I think I have a way to find like the first match. Give me a sec. Yeah, so it's basically this. But actually, no. We should do basically this function, but without the loop. It's basically that. Right, so without being going recursive, so just quit on the first match. Huh. Or I guess we could pass it as an option and save us from writing two functions. Nice. Okay. So, oh, but this one is expected to return a. This one is expected to return an array. So. All right. Okay. Let's just duplicate them and be done with it. Because you know, I don't mind having to add an option, but the thing is, if I have to mess around with what the return type is, that's not a good idea. Anyhow. It leaves and defined and not defined. Right, so if we still have not actually, let's do it the other way around. If we have not found a match, then keep looking. But if we have, just return it. And that's that. Okay. So yeah. It's very much the same function. But basically, yeah, it would take me rethinking the whole thing. And I want to get this done like now. Right? So when people want to get things done fast, usually what they do is they download libraries. What I do is I make the half-fast implementation as fast as I possibly can. You know, just do the thing. Okay. Same thing in here. Actually, what I should do. Right, because one is doing a while and the other is jumping. I should do this with both, actually, now that I think about it. Because it's essentially the same thing. Like what exactly is the difference? Yeah, I'm sorry, I'm trying to figure out what the difference is. There is a slight difference, yes. There is a slight difference. But I think Okay, so I do like go to, okay? I do like go to, but in this case we can do better. In this case we can do better. Okay. And same story. If we found something, we just quit, and if not, we just keep recursing. So nice. Okay. I should fix the other one as well, but I'm not gonna. I should fix the other one as well, but I'm not gonna. Okay. So now instead of having to do all of this, I can just call it like so, and it should get you the first match. That's the point. So if you have like a very specific search, there you go. Okay, and so now we can say and now we can do this with a map. Makes more sense. Oopa! Not quite. Okay, so I must have forgotten to change some value in here. There's 1397. Okay, yeah. Oh, and I can break right away. One less check. What do you mean? 48. Oh! There you go. Alright. Nice. Okay. So basically, we find the package with the given name, and within that package, all of the globals, right? And so we can zoom in into the piece of code that we want to analyze, right? And so with this, we can do a very precise, very precise parsing of a Perl file, for the purposes of code analysis, but we're still kind of doing something pretty fucking great. So yeah, I'm proud of this. And well, just to show off that this actually works, it's just print the old package just to be. Right. And as you can see here are the subroutines we've been editing, right? So we just modify the node class to more precisely parse the node class, okay? And here are the hour, right? The version and the other thing, the author. That's the only reason I use hour. Okay, and there we go. That's basically that's a wrap. Okay, so yeah, that's very much it. I do think that maybe having like this thing in here at the top might not be the best approach visually, but just for the purposes of finding things, yeah, you know, it's kind of like having the dot, right? It's kind of like having the dot at the top of your directory, right? At the top of your folder structure. You know, like normally you wouldn't, you don't want to see it, and normally you don't see it, but yeah, it's kind of nice to have it there, right? It does a little bit of something. So yeah, that's a wrap. We can expand our files into node trees. So that's pretty fucking nice. So yeah, that's it from me. Have a good one. Bye.